In this video, we're going to go over the answer key for Wednesday, April 1st. And our topic today are buffer solutions. And a buffer solution is just a solution that's made out of a weak acid and a weak base. And they have to be conjugate pairs. That is, when the acid breaks down, it forms a base, and when the base gets a proton, it gets an acid. So you can see, for our example, acetic acid and sodium acetate, they just really differ from one hydrogen. This sodium is just a counter ion, so it really doesn't come into play. To determine the pH of a buffer solution, we use the Henderson-Hasselbalch equation, where it's pH equals pKa plus log of concentration of base divided by concentration of acid. Remember, these brackets mean concentration, so that's moles divided by liters. All right, so our question one, I have a bunch of different bases and acids, different buffer solutions. So I'm asking you to solve for the pH, so we're going to do the first one. So the first thing you want to do is figure out what your acid and what your base is. And so the difference is going to be which one has more hydrogens. The acid should have one more hydrogen. All right. And if we look at this question, we're given grams in milliliters, but we want molarity. So what I'm going to do after I figured out what's my acid and what's my base is I'm going to switch both of these to molarities. So I have 15 grams of hydrofluoric acid. Molecular weight is 20.01 grams per mole. So put 20 grams on the bottom, 1 mole at the top, and we find out the molarity of hydrofluoric acid is 0.750 moles. Or rather, the moles are 0.750 moles. To get molarity, I need to divide by volume. Volumes in liters, I have 125 milliliters. So I take 125 milliliters divided by 1,000 milliliters to get 0.125 liters. So I take my mole divided by my liters to find 6 molar. For my base, I'm going to do the same thing. 25 grams of sodium fluoride, 14.99 grams per mole. I get 1.67 mole divided by 0.125 liter. It's the same volume because they're in the same solution, and you get 13.36 moles. So I have my first part of the Henderson-Hasselbalch. Now I need Ka and pKa. So Ka is 3.5 times 10 to the minus 4. pKa, anytime you see a P, just like for pH, that means minus log. So pKa is minus log Ka. So it's minus log 3.5 times 10 to the minus 4. pKa is 3.46. So pH equals 3.46 plus log of 13.36 divided by 6. pH equals 3.46 plus 0.35. So the pH of our solution is 3.79. Which makes sense. We have more moles of base, so our pH should be higher than our pKa. If you have more moles of acid, it should be lower than your pKa. Alright, and now since we know how to calculate pH, briefly how do buffers work. So a buffer will resist pH change. So if you add an acid to a buffer, it will react with the base in that buffer and neutralize. If you add a base to a buffer, it's going to interact with the acid of that buffer and also neutralize. So question 2, I have a buffer of sodium acetate and acetic acid. What's the pH? And I'm going to do B as well. What's the pH of after adding 0.0050 mole of hydrochloric acid? So the pH is what we just did. pH equals pKa plus log of base divided by acid. pKa is 4.75. Acid's acetic acid, base is sodium acetate. Already gave it to you in molarity. So I just do pH equals pKa, 4.75, plus log of base divided by acid, 0.250. pH equals 4.75. The log of 1, 0.250 divided by 0.250, which is 1. The log of 1 is 0. So when your base and acid concentrations are the same, pH is equal to pKa. Now B, what happens when I add 0.0050 moles of hydrochloric acid? So the first thing you should do is write down your chemical equation. In your acid, hydrochloric acid will always interact with your base, sodium acetate. And what you're always going to make is your conjugate acid. So you're going to make acetic acid by doing this. So hydrochloric acid plus sodium acetate makes acetic acid plus NaCl. Now I'm just dealing with pH here, so I don't care about NaCl, but I do care about the amount of sodium acetate and acetic acid. So I'm going to make an ice table. So initially I have 0.0050 moles of hydrochloric acid, and I need to figure out moles of sodium acetate and acetic acid. When you're doing ice tables, you need to be working in moles. So I take my sodium acetate. My molarity is 0.250 moles in 1 liter. I'm going to take that 1 liter, convert to milliliters. I have exactly 250 milliliters of solution, so milliliters have been canceled out, liters have been canceled out, and I have 0.0625 moles. So that's how many moles of acetic acid and sodium acetate I have. And they're the same because they're the same molarity and they're in the same volume. So both 0.0625 are my initials. Now, an acid and a base react completely. So whatever runs out first, or whatever your smallest number is, it's going to go to 0. So my moles of HCl is less than my moles of sodium acetate. So I'm going to lose all my HCl. So minus 0.0050. Minus 0.0050. And your reactants make your products. My sodium acetate makes my acetic acid. So this is plus 0.0050. So my HCl is all used up. My sodium acetate has been decreased to 0.0575. My acetic acid has been increased to 0.0675. Now I can do the Henderson-Hasselbalch equation again, where pH equals pKa plus log of base divided by acid. So I need to find molarities. Remember, when you're doing brackets, you need to do moles divided by liters. So I just got my moles. Now I need to figure out my liters, which is given in the problem, 0.250. So my molarity of sodium acetate is 0.0575 divided by 0.250 equals 0.23. Acetic acid, 0.0675 divided by 0.250 is 0.27. So Henderson-Hasselbalch, pH equals pKa, 4.75, plus log of base divided by acid. Sodium acetate is the base, acetic acid is the acid. Your pH is 4.68. Alright, and that's the last problem set for test 3. So if you have any questions, again, please email me and we will get those answered. Otherwise, I will see you in the next video.